In this video, we're going to use the first derivative test to find local extrema of an algebraic function. It says use the first derivative test to find the location of all extrema for the function given below. Enter an exact answer. So the first thing I'm going to do is find the derivative of the function. So I'm going to say f prime of x, and I notice I have 4x times root 1 minus 5x. That's a product rule. So I'm going to go ahead and write u is equal to 4x. U prime is equal to 4. When I take the derivative of 4x. B is 1 minus 5x to the 1/2. And v prime would be 1/2 1 minus 5x to the negative 1/2 times the derivative of the inside. So 1 minus 5x. When I do the derivative of the inside, I get negative 5. So I'd end up with negative 5/2. 1 minus 5x to the negative 1/2. And then we can take that and we can do the product rule here. So we can do u times v. So we'll have 4 times 1 minus 5x to the 1/2. And then we'll do u times v prime. So we'll have negative 5/2 times 4x. And then we'll have 1 minus 5x to the negative 1/2. I'm going to do a little bit of simplifying here. So we're going to end up with 4, 1 minus 5x to the 1/2. And then let's see here. We're going to have minus, let's see, that'd be 20x over 2, so that's just 10x. 1 minus 5x to the negative 1/2. And we're going to set all this equal to 0, and we're going to find the critical points for this function. So to do this, what I want to do is I want to I'm going to write this as, I'm going to find a common denominator here is what I'm going to do. I think that's probably the best route. Yeah. So I'm going to go ahead and write this as equal to 4, 1 minus 5x to the 1/2 minus, this will be 10x over 1 minus 5x to the 1/2. And we'll find a common denominator, combine this together. So I'm going to multiply this fraction by 1 minus 5x to the 1/2 over 1 minus 5x to the 1/2. So I'm going to have this as being multiplied times 4, 1 minus 5x to the 1/2 over 1 minus 10x over 1 minus 5x to the 1/2. When I multiply on top, I'm going to end up with 4 times, if I take 1 minus 5x to the 1/2 times 1 minus 5x to the 1/2, they're like bases, so I add the powers. 1/2 and 1/2 is 1. So I end up with 1 minus 5x over, and actually, okay, I'm going to write this, over 1 minus 5x to the 1/2 minus 10x over 1 minus 5x to the 1/2. And then I'm going to say that that is equal to, let's distribute here, I get 4 minus 20x minus 10x over 1 minus 5x to the 1/2, which is going to equal 4 minus 30x over root 1 minus 5x. And now I'm going to find the critical points based on this being equal to 0, this equation here being equal to 0. And so one thing I want to notice is that I have some domain restrictions here. So if I set the numerator and the denominator right now equal to 0, I'm going to be able to find the critical points, because if I set the denominator equal to 0, I'm going to get the values that that cannot work for the function. And then if I set the numerator equal to 0, I'm going to find the values where this function is actually equal to 0. So I'm going to do both of these things. I'm going to say that 4 minus 30x is equal to 0. And then I'm going to solve this by subtracting 4 on each side. So I get negative 30x is equal to negative 4. I'm going to divide by negative 30 on each side. And I get x is equal to 4 over 30, which would be 2 over 15. And then I'm going to do the same thing with this root. I'm going to say that root 1 minus 5x is equal to 0. Square each side. So I end up with 1 minus 5x is equal to 0. Subtract the 1, so negative 5x is equal to negative 1. And then we'll divide by negative 5 on each side, so I end up with x is equal to 1/5. So I found two different critical points here. So now I'm going to do the first derivative test. And I'm going to draw that out here. So first derivative test will be right here. And I'm going to mark 2/15 and 1/5. So 2/15 is pretty small. And then I've got 1/5 here. And I'm going to use 0 for a test case. 1/5 is the same as 3/15. So I needed something in the middle between 2/15 and 3/15. So in the middle between those would be, let's change these to 30ths. That would be 4 over 30, and this would be 6 over 30. So I'm going to use 5 over 30 here, which would be 1/6. So I'm going to test 1/6 here. And then I'm going to test out here just the number 1. So slide up just a little bit, and we're going to do f prime of 0, f prime of 1/6, and then f of 1. And we're going to test these out. So I'm plugging all of these into my first derivative, which technically this is the most simplified version of my first derivative. So this is f prime of x. So I'm going to go ahead and plug that 0 in here. And I get, for the first part, I get 4 minus 30 times 0 over root 1 minus 5 times 0. When I do that, I end up with 4 over root 1, which is 4. Now I'm going to use a calculator to do the next two. So I'm going to plug them in. So I'm going to store 1/6. when I plug it in, I get a negative number. So this is negative 2.449. So I went from positive here with that 4 to negative. Now I'm going to plug in 1. And when I plug in 1, well, I can't even plug in 1 because 1 is not part of the domain of this function for the derivative. So I've got 1/5, which yeah, I can't plug anything in past 1/5. So really, I can ignore this point completely, right? Yeah, I can ignore that point completely. So that's what I'm going to do is I'm going to ignore this point completely. And this tells us that we have a local maximum at x equals 2/15. And then for local minimum, we would have the empty set. We don't have anything there.